Assalamu alaikum. Welcome to Digital Electronics Lab. So this year we have decided that we will be giving you guys a project that is called Digital Snake Ladder game. Okay. So I think all of you are familiar with the Snake Ladder game. How does it work? How to play? Uh, but if not, let us go through a brief explanation. The Snake Ladder game, you have from 1 to 100, you have different blocks, okay? 1, 2, 3, 4, 5, 6, like this. And in each of these blocks, there are certain players, okay? There you might have one marker for one player and another marker for another player. They might be of different colors. So you have player 1 and player 2, two players, okay? You might have a round coin shape something or whatever you might have that is actually used for a marker, okay? Now you can see you have 1 to 100 mark, okay? And how one player advances based on a dice roll, okay? The dice roll actually introduces the randomness, and based on that randomness you actually advance. Let's say you have rolled a dice value 3 for the player 1, then player 1 will advance 3 squares, okay? And similarly you can see there are different snakes and ladders in this game. So what happens, let's say if you are in one ladder, let's say you are at this position in the bottom of the ladder. Next, if you land on this position, you would be promoted on top of the ladder, okay? From 4 you will go to 56. And likewise, if you actually land on the mouth of a snake or a head of a snake, then the snake will eat your player and you will go through its tummy to the tail of the snake, okay? So the objective is actually to who reach 100 position. Whoever reaches to this position first will actually win the game, okay? Now let's say player 1 is player 1's turn and he rolls the dice. So let me roll the dice, okay? So player 1 has rolled the dice. You can see 2 has come up. So that means player 1 will actually advance 2 position. So 2, 3, he will go from position 1 to position 3. Okay, so he will advance 2 position. So player 1 has advanced to 2 position. Now let's say it's player 2's turn. And he rolls the dice. And he gets, as you can see, 5, right? So he will advance 5 position. So if he advances 5 position, what does it mean? His current position is what? 1, right? So as his current position is 1, okay. So if you just add the dice value, that is 5, you will get his next position. This is actually our inherent logic of snake ladder game. This is your current position C, and this is your dice value D. So if you just add these two, you will get your um, next position. So you will just advance five squares, okay? 1, 2, 3, 4, 5. So you will go to 6, okay? So you just add your current position here, current position with the dice value, okay? And you get your next position. All right. Uh, okay. Now let's say again it's player one's turn. So they take each turn one by one. So let's say it's player one's turn and he is now going to roll the dice. He has gotten the position 1. Can you see? The dice value 1. See? So he would advance 1 value, right? So his current position is 3. So you just add 1, you get 4. So he will advance by 1 position. So that will be 4, right? But 4, you can see you have a ladder here. That means the player 1 will be promoted through this ladder to 56. Similarly, you're playing, and somehow if you land on this, let's say 96, what will happen? Well, after playing for some time, you land on this 96, you would be eaten and you would go to this 42. So if you land on this 96, you would just go to this 42, okay? And the first player to reach the final square, the 100, this is actually your winner, okay? Now we're gonna model this using our digital logic circuit, okay? So as you can see, this is your architecture, or this is the main theme of your digital snake ladder game, okay? Now some of the features you must have, okay, in your digital snake ladder game. We have broken down those things. So let us first see this one, the dice module. Okay, the dice module is this one. This one is your dice module. Here, actually, you generate a random number between 1 and 3. Okay, how do you do that? We would see the details of each of these blocks a bit later, but this is your dice module. Now, in this case, you can see there are some LEDs and how these things work. I will explain this in detail a bit later, but for the time being, you can see these are just the each block has 4 LEDs, and each of the block is one position. Okay, so this is one position, this is another. Zero is one position. You had 0 to, oh, sorry, you had 1 to 100, right? So you have 0 to 15. These are your actually blocks. Okay, whenever player reaches this 15 position, he wins. Now, dice board module gone. One thing here as well, uh, the snake ladder logic module, you have to understand, this is actually the heart of our architecture. In this case, you can see, let's say a player has rolled a dice and the dice value is 2, right? This is the dice value. 2 is the dice value, and he is currently at position 7, so this is his current position. C for current position and D is the dice value. So how much should he advance? He should advance by 2 position, right? So he should advance by 2 position. That means he should now go to, you add this 2, you will get 9. So he will be at now block 9. Okay. uh, so what does the snake ladder logic do? It will just add these two and it will find the position where it should go, right? But one thing it also does, actually, it checks for ladder start or snake head, okay, or snake start, whatever you can say. uh, let's say you have rolled a dice and you see, okay, I need to advance by 2 positions, right? But after advancing, you see there is a ladder or there is a snake, right? So you need to account for that. I would explain this in detail, no worries, but it accounts for that as well, and it gives the output as selected player's next position to the game memory. Okay. uh, and one thing as well, you can see here, these are some of our inputs: ladder start, ladder length. Ladder start is where the ladder will start. Okay, so in the board 0 0 1 1, so that means ladder will start at 3, and ladder length, this is what, 5, right? So ladder length is 5, that means the ladder end position will be what, 5 plus 3, 8, right? Similarly, snake start, or this you can say it as snake head as well, doesn't matter. The snake head is actually 12, right? Then if you snake length, right? Snake length is what, 10. This is 10, right? So if you decrease these two values, I mean, if you subtract these two values, you would get actually the tail of the snake. You have the head of the snake. If you just subtract these two value, you would get the tail of the snake, right? So the tail is 2, right? uh, so I would explain this thing a bit detail, but I'm just giving you an overview. Okay, you have next, you have the player selector module. This is the player selector module. Which player will be currently playing? You just push a button and you toggle between player 1 and 2. You have the memory module. The memory module actually stores the position of the players, like what is the current position of player 1, what is the current position of player 2. This is stored in the memory module. This is that. You have the reset module. This is the reset module. Whenever you press this, your entire, I mean, game resets to 0 0 position. Okay. You have a decoder module. Basically, the decoder module, let's say your game memory gives you output as 0011 for player 1. This is the player 1's current position, or let's say whatever, 0100. So you need to actually light up the corresponding LED, and you need to do it using a decoder. Okay. Similarly, the all of the LEDs you need to light up using decoder. So you would learn about this thing a bit later in detail. And also the winning module. The winning module actually signals if, let's say, one of the player reaches the end position. We have total 16 blocks, right? These are from 0 to 15. So if any player reaches the 15 position, then he will actually win. Okay. So this is our entire architecture, you can see at a glance. Now I have given some legends here: player 1, player 2, ladder, snake. You will be given a project manual, don't worry. And also 1 bit, 2 bit, 4 bit, 16 bit. Okay, these are all given. So let us look at each individual blocks one by one. Okay, so first of all, we're going to look at the dice module, right? So the dice module will generate a random number between 1 and 3, right? 1 and 3. So you need to skip the value 0, obviously. How does it do that, right? Whenever you press the dice button, try to listen to this thing carefully. Whenever you press the dice button, there is a counter, right? There is a counter, and this counter cycles from number 1 to 2 to 3, but this cycle is very fast, very fast. Again, it cycles, it goes back to 1, again 2, 3. It cycles between these two numbers very fast. So when you press the button, there is a second segment display here. This is a 7-segment display. Okay, you would see that the numbers are cycling from 1 to 2 to 3 to again 1 to 2 to 3 very fast. So you cannot see which number is actually there. So the numbers are cycling very fast, and when you release the button, that will be your actually dice output. Okay, so, and also there is one thing called debounce circuit. This is basically for your hardware part. I'm just showing you a bit. Whenever switch is unpressed, you can see this is the 0 value. Then whenever you press a switch, there is some bouncing here. Okay, bouncing, this causes some disturbance in the hardware circuit. Software, there is no problem with debouncing, but in hardware, this is the main problem. Okay, now look at this. Can you see that the number is cycling from 1 to 2 to 3 very fast? So when you press the dice button, let me play this video again. The number is cycling between 1 to 2 to 3 very fast. And when you let go of the button, that is actually, it will be fixed at one number. You cannot actually predict which number you would be giving because it's cycling so fast. So what happens is that when you let go of the button, let's say in this case 1 is there. So when you let go of the button, 1 has been pressed. Okay, it shows that 1 is here. So it cycles very fast, 1 to 2 to 3 when the button is pressed, and when the button is released, the number that you get, it will be shown, and that is your dice's value. Okay, so the unpredictability comes from releasing the dice. Okay, so the timing, okay, that is the unpredictability factor here. Let us move on. So this is one of our most important things that you need to understand. This is the board module. Okay, now the board module is played on a 4x4 grid. Okay, so 4x4 grid, that means you have 4 rows and 4 columns. Okay, and you have total 16 positions. In previously you had 1 to 100, but you have 16 in this case. Okay, which are from 0 to 15. Okay, this is one position, this is another position, whatever. Okay, next, each of the position has 4 LEDs. 1, 2, 3, 4. Okay, so you have 4 LEDs. This is a red LED, this is a blue LED, as you can see, and you have this one, this is a yellow LED, and this is a green LED. Okay, so this pattern are repeated all over the board. Okay, so this red LED, the first one, this is for your player 1. Okay, this is for your player 2, and this yellow LED is for your snake, and this green LED is for your ladder. Okay, now if you can see, at position 3 this green LED is lit up, and at position 8 the green LED is lit up. That means there is a connection between position 3 and 8 by a ladder. Okay, which means that if any of the player LEDs can move from here to here, let's say it can move from here to here, again it can move from here to here. So whenever the dice is rolled, the player it advances. Okay, so the player LEDs advances, and this one you can see the green LED here, this is the green LED. Okay, this is in the position 3, and this green LED is at position 8. So there is a link between these two. So if a player somehow, player 1, let's say it lands on here at the third position, at the third grid, not third grid, sorry, fourth grid, or the 3 position, whatever you want to tell. Okay, so at the 4th grid or the 3 position, basically, if it lands in this position here, okay, the player 1, then what will happen, he will be promoted through the ladder to here. Okay, similarly, let's say a dice is roll, and somehow one player actually goes to this 12th position, right? So player 1 goes to 12th position. Can you see there is a LED here? Okay, let us look at this. There is a yellow LED. That means the snake LED is lit up here and here. That means if a player lands on the higher, always the higher value is the head. Okay, in the snake LED, the higher value is the head. Okay, which means if a player lands on this box number 12, he will be eaten up and he will go to this box number 2. Okay, so that was actually an overview of all the things. So player LEDs, these red and blue LED, they can move. Okay, they can move from one block to another, and they move how? Based on the dice roll. Okay, the player LEDs, and also these, I mean, green LED and the yellow LED, the snake and ladder LED, they are static. Okay, so let us look at one example. Let's say this is the player one's turn, and player one has gotten the value 2, right? So what will happen? The player 1 will advance 2 position. So his current position is 0. So if you just add 2, he will go here, right? So he will advance 2 position, 1 position, 2 position. Okay, you can see this player has advanced 2 position. Now let's say it's the player 2's turn. The blue LED is the player 2's turn, and player 2 rolls a value of 1. That means he will advance by 1 position. As you can see, he has advanced by 1 position, right? Now again is the player one's turn. So the turn actually cycles, and now player 1 actually have now landed a dice value of 1. Okay, that means he will advance by 1 position. But can you see here 3, there is a ladder. That means he will be promoted through this ladder to this 8 position. Okay, so the player 1 goes to 3, but in 3 there is actually what? A ladder. So he will be promoted to position 8. Similarly, after playing so long, if you just go to this 12th position, what will happen? Let's say player 2 goes to this 12th position. What will happen? There is a snake head here, right? So he will be eaten, and he will again go back to this 2. So yeah, that's pretty sad, but I mean, this is completely randomness. Okay, so this game actually works on based on randomness. Next, the most important and the heart of our, I mean, digital snake ladder game is our snake ladder module. Okay, so the snake ladder module actually finds out the next position after you have pressed the dice. Okay, so calculates the next position based on dice roll. That means when you have pressed the dice, where will the player move to? Let's say you have pressed a dice value, right? You have pressed the dice and one value between 1 and 3 has come up. Now where will the player go? I mean, what will be its next position? Let's say it advances 2 position, but it sees, oh, there is a snake. Then that value has to be decreased, and he will go to the tail of the snake because the snake will eat the player. Or let's say a player advances, let's say 3 position, and he sees, oh, after advancing 3 position, there is a ladder. So he need to be promoted up the ladder, right? So this is actually uh, the main logic of our circuit. It actually calculates the next position. Okay, so based on, okay, this is given here based on dice roll. That means what is the dice, that value that has been gotten in this case, and also selected player's position. Okay, uh let me go a bit. Okay, let me look at the inputs first, right? So the input, one of the input is ladder start and ladder length. Okay, um, because let's say you, is there any ladder, right? If you advance 2 position, let's say you are at 0 position, you have advanced 3 position, but at 3rd position you saw there was a ladder, right? So you need to take account for that, like what will be the next position. The next position cannot be 3 because there is a ladder, so he will be promoted up the ladder, right? So you need to actually think of, like, you need to take the ladder start into the snake ladder logic, then ladder length, then snake start and snake length. All of these things needs to be taken into account in the snake ladder logic module, right? So the ladder start, as you can see, 0, 0, 1, 1. So ladder start is 3 here, as you can see, 3, and ladder length is what, 5. So if you 0, 1, 0, 1, this is 5, right? So if you just add these two, ladder start and ladder length, you will get your value, which is 8, right? So this is the end of the ladder. Similarly, the snake start is what, 1, 1, 0, 0, which is actually what, 12, right? So the snake head is at 12. Now snake length is what, is 0, 1, 0, which is 10. That means if you just subtract these two, the snake head, from the snake head, if you just subtract the snake's length, you would get the tail of the snake, right? Okay. So these things actually goes into the snake ladder logic module, because it needs to predict, okay, I have advanced 2 position based on the dice roll, but at that tentative position, is there any snake or ladder? I need to take account for that. That is why ladder start, ladder length, these things are input to the snake ladder logic module. And the output is, you can see, selected player's next position, right? The current selected player's current position from the game memory is also input to the snake ladder logic module. Okay, this one, this one. Okay, wait a minute. Okay, you can see here, selected players selected player's current position. From the game memory, the current position comes into the snake ladder logic, and also the dice value after each spin. So these are the two inputs to your these are the one of the two inputs to your snake ladder logic module. Also, you have these things, you have seen these things, these are the ladder start, length, those stuffs. Okay, so here I've just written some points for you, and just for snakes and ladder I've told you about this. Okay, you might use adders and comparators to check for ladder or snake encounters. Okay, and moves players up and down accordingly. Okay, I have also told you about that. Okay, one thing is optional here. Priority logic handles conflicts, favoring ladders over snake. Okay, this is one optional thing. Let's say in the same position you have ladder and snake, what to do? Then you can favor ladder. Okay, in that case as well, this is an optional priority logic. Now I have shown you the ladder start, ladder length, those things, and the output is player's next position, and also the carry out, right? If there is some overflow case and you need to handle that to the game memory, then you need that information, right? So that is also a carry out that is needed. Okay, you can design it by your own, what do you want to do with the carry out. Okay, and moving on, our next module is the player selector module. Okay, this is a very simple module. It selects which player is currently active, right? Your game memory actually stores the player, this game memory stores your current position of your player, right? What is the current position of both of the player, it is stored in the game memory, right? So the player selector actually gives a signal to the game memory, okay, which player is currently playing, is it player 1 or is it player 2, right? So allow switching between player and player 2. This you can use a switch or a toggle. Okay, and this sends a logic signal. You can see logic signal indicating the current active player. That means which player is currently playing. Let's say you have rolled the dice and you need to advance by 2 position, but which player will advance by 2 position, player 1 or player 2? That is actually determined by this player selector module. Okay, and the updated position is stored in the game memory, but it whose updated position, this is actually selected by your player selector module. Okay, uh, and pull down register, debounce circuit, these things you can use. Okay, and you can use led to actually show visually which player is currently active. Okay, moving on, one of the another important module is our game memory module. Okay, so here you have a high frequency clock. You will need a clock for your game memory, obviously, but you can, if you want, you can also try to design it without clock, or whatever way you want you can design it. But you have to understand what does it do. It stores the current position. You can see it stores the current position of both players. That means, let's say you have you are at a certain point in the game and you have not pressed the dice, right? So the both of the, let's say player 1 is at position 5 and player 2 is at position 12 or 14, whatever. So these current position of the players, both of the players, they are actually stored in your game memory, right? And you can use a demultiplexer, okay, to select which register will be written. Let's say you have pressed a dice button. Okay, I will show you in detail a bit later. Also, there is also more detail coming up. But let's say you have pressed a dice button for player one. You have player one and you have pressed the dice button. Now, there is no snake and ladder, and the dice has come up that you have to actually advance two position. So what is happening? Try to understand this thing. You have pressed the dice for player one, and it is saying that okay, uh, advance by two position. The dice value is now two, right? So it will advance by two position. Now the snake ladder logic module actually sees that okay, there is no, I mean, snake head or ladder start. So okay, advance by two position, then selected player's next position. This goes into your game memory. Okay. Now selected player's next position actually goes into game memory, but which one, right? You have pressed the dice button, but which player? So there is a logic signal that comes up to the game memory that which player has been selected, player 1 and player 2, and his position will be updated when the dice is pressed. Okay, only when the dice is pressed, at that moment your, I mean, player's position will be updated based on the snake ladder logic's output, right? The snake ladder logic actually gives you where you should, what will be the next position. Okay, now you can use a demultiplexer to select actually player one, because there will be two memory modules for player one and player two. So you can use a demultiplexer to actually select the appropriate register where you should write based on the active player. Okay, so you can see player selector, there is an input to the game memory, and also the dice button, because only when the dice is pressed you will actually update the memory, because if that dice is not pressed, then why will you update the memory, right? And okay, I have told you about this thing. And use just flip flop resistor, you can use whatever you want in this circuit. And also there's a reset button. Whenever you press this, both of the player, no matter where they are, they go to their initial position, that is 0 0. Moving on, the reset module. Okay, I have told you about this reset module. Basically resets the game to initial state without power cycling. You don't have to turn on and off, you just press this button and everything initializes to 0 0. The both of the player come to their initial position. Okay. Okay, one thing, you can also use an optional LED to show if the game is ready for restart or not. It is completely optional. Okay. Now we're gonna move on to the decoder module. The decoder module, you can see the ladder start is 0011. That is what, 3. That means the LED at the third position should be lit up. So the ladder start position goes to a decoder. This is a very simple decoder. It goes to this decoder, and this decoder actually lights up this third LED. And you can see the ladder length is 5, right? So you just add 5 value. So 5 plus 3 is 8, so you light up this 8 block. Okay, and this ladder position decoder, it actually decodes which LEDs to light up. Similarly, the snake position decoder, the snake start is 1100. That means 12 position, so the 12th position is lit up, and the snake length is 010, so this is 10. So if you just, your, I mean, snake head is at 12 and your snake length is what, 10. So if you just decrease 10 from if you just decrease 10 from the 12, you would get 2. So this is the snake's tail, and the snake position decoder just converts this binary value into the corresponding LEDs. Okay. Eh, okay, and uses current limiting. Okay, you can use current limiting resistors. When you're using LEDs, you need to use resistors, current limiting resistors. Okay, especially for the hardware cases. You can see you have player 1 position decoder, player 2 position decoder. I've previously told you the game memory stores the current position, the present position of the um, player 1 and player 2, right? So let's say the current position is, okay. So the current position is what, let's say 0 1 1 1. This is the current position. Okay, game memory for player 1, this is the current position 0 1 1 1. So this goes to the player 1 decoder, and player 1 decoder actually lights up the respected LED, okay, for 0 1 1 1. Okay, similarly player 2 position decoder, let's say the player 2 position decoder is, so where it will be, so it lights up that LED. Okay. Oh, one thing, I think I missed one thing. Okay, one thing is it receives 4-bit position input. Okay, so this is the 4-bit value. This is a 4-bit value, and it actually uh, lights up that corresponding LED based on that 4-bit value. Okay, and you can see how, what is the, I mean, decoder. It will be 4 to 16 line decoder. Okay, 4 to 16, because the input is what, 4, right? So input is 4 because it's a 4-bit value. And how many LEDs you have? You have 16 LEDs for player 1, right? So you will have 4 to 16 LED for this one. This is again 4-bit input, and the output is what, 16 LEDs. So 4 to 16 LEDs. Okay, and also at the same time both of the LEDs can light up. This is very simple. Okay, winning module. You have a one module that is called a winning module. Let's say when a player wins, whenever he reaches the final position, right, or the last position, that means, let's say player two has reached this position, right? That means he has actually won. So you need to actually light up a corresponding LED and a buzzer to show, okay, player two has won. So this is a winning module. So let's say you have player 1, player 2 here. So player 2, you have one LED and one buzzer. Okay, so one buzzer and one LED. So if player 2 wins, that LED and that buzzer will light up. Okay, so whenever a certain player reaches the last position, then actually you can use this one to show, okay, he has won. And now let's light up the LED and buzzer to show, okay, player 1 has won or player 2 has won. This is very simple. You can use comparators. Okay, you just compare this value with the current position. So if you have just, let's say, 1 1 1 1, this is the winning position, right? So you compare it with your current position. If the current position they match, then okay, he has won, and light up the winning circuit. So till now I have gone through the entire process, okay, of the snake ladder logic. Now I'm gonna show you how does this thing work step by step, like with bits. Okay. So can you look at the game memory module? In the game in the game memory module, you can see currently both of the player is uh, at 0 0 0 and 0 0 0 position. That means both of them are at the initial position here. Can you see? Now we're gonna play the game, okay? And I'm gonna show you some instances how does this thing work. This will help you clear out any confusions that you have. Okay, so let us start playing this game. How does this thing work? Let's say you have pressed the dice button. You have pressed the dice button and it's spinning, 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 and the value comes up at 0 1 0, right? So 0 1 0, the value is come up. That means that your current player selector, which is the current, okay, let me get this one, laser point. Okay, current player selector, you're currently at player 1, right? So player 1 has pressed the dice and it has cycled from 1 to 2 to 3 and is cycling very fast. After he has released the, I mean, button, dice button, you can see that this is the dice value after spinning. Okay, 0 0 1 0. Now this goes to your snake ladder logic module. So this is your dice value, right? Now what is the current position of your player 1 in the game memory? You can see 0 0 0 0. So this comes to the snake ladder logic module. You can see current position through here, selected player's current position. This is an input to your this module, right? Now your current position is this one, 0, right? And you have gotten what, 0 0 1 0. That means you should advance two position, right? You should advance two position. So if you just add these two value, dice position with your current position, you will get your tentative position. Why tentative? Because let's say you have got advanced two position, but here is there any snake and ladder you need to check, right? Specifically you need to check, is there any ladder start? That means if there is a ladder start or ladder's bottom, you need to be promoted, so you need to check the ladder start, or is there a head of a snake? Because if there is a head of a snake, then that will eat me. So you need to check that if there is a head of a snake, or is there a ladder's bottom or ladder start, right? So this is your ladder start 0011, which is basically 3 here. So that comes up. So this is the ladder start value and your snake head, right? This is your snake head. Now your tentative position is compared. You can use a comparator or whatever logic you want, doesn't matter. You check the tentative position with the ladder start. Do they match? No, there is no ladder start at the tentative position, so you don't have to think about that. Again, your tentative position, does it match with snake's head? No, so no snake will eat me. That means this tentative position is actually now your uh, next position, or this is the final position. There was no ladder, there was no snake, and this is your uh, now you can proceed. Okay, so selected player's next position, it is now updated into the memory. Okay, and the memory is only updated because you have pressed the dice. Okay, so this is 0010, but now you need to also update the, I mean, yeah, board, right? You need to show the output in the board. So this goes to the player one position decoder 0010, and 0010 is what, 2 here, right? So you should light up this LED. So this LED is now lit up, right? So now player 1 has played. Now is whose turn? Is player two's turn. So now player 1 is, you can see this is our next round. Round 1 has finished. At round 1, player 1 has gotten the dice value. Okay, and now his position has updated. You can see player 1's position is now updated, this one, and the corresponding LED is now this one, has been lit up, right? Although there is a snake LED, I mean, glown up, but this is the tail of the snake, so it doesn't matter. This is the tail. If it was a head, then that was a different story. Okay, now it's player two's turn. You can see player selector is now here. It's player two's turn. Now player 2 has pressed the dice. Let's say he has pressed the dice button, and the dice is cycling between the number 1 2 3 1 2 3, and he lets go of the dice and he gets the value 0011. That means this is the value, the dice value that the player 2 is now pressed. Okay, so player two's dice value, he has rolled the dice and he has gotten this value. So the dice value comes up here. This is a dice value, right? And the current position, player two's current position, selected player's current position, as you can see here is written in detail. Selected player's current position is now coming up here. Can you see? Selected player's current position, that comes up here. Okay, so what will be the tentative position? Basically, you add the dice value with the current position. This is your tentative position. So player player 2 should advance by 3 positions, 1 2 3. But here is the catch, there is a ladder, right? So I told you previously, we need to also, after this is not our final position, this is the tentative. You add the current position with the dice value, but this is not your final position, this is the tentative position. Okay, so after you find the tentative position, you need to check for snake head or ladder start. Okay, right? So this is your ladder start value, and this is your snake head. So as you can see, the tentative position and the snake head, they do not match, but the tentative position and the ladder start, okay, ladder start, these three, they match. That means whenever player 2 will advance by 3 position, he has gotten to the bottom of the ladder and he needs to be promoted to the top of the ladder, that is at 8, right? So what he needs to do now, he needs to go to position 8. So how would he do that? What is his position? 3, right? Tentative position is what? 3. So you just add the ladder length with this tentative position. Ladder length. you just add the ladder length with the tentative position. Tentative position what 3, right? If you add just ladder length, that is 5. Ladder length is 5, right? So if you just add 5 with 3, you get what? 8. So 8 is your, I mean, jump to ladder top. 8 is your now actual position, that you will be promoted to the top of the ladder, and you should go here, right, at the 8th position. So 1000 or 10000, this is your actual player two's position. Now this will go to your player two's memory, and also the corresponding positional decoder 11000, it will actually lit up the eight position, right? So it will go through here, and this 8 position will be lit up, right? So this is how actually you play this snake ladder game, and you design this snake ladder game. um you can design it in many ways. All the flexibility will be given to you, but some things you need to actually incorporate, and I have given you an overview of the whole thing. And similarly, if you're at snake as well, if you see your snake start is here, just decrease that value, right? Tentative position you have just added with your ladder length, right? But if you just uh, if it was a snake, then you just decrease the value, right? You just subtract the snake length, and you would get the to the bottom of the snake, right? So this is how actually your entire game is played. So thank you.